Hello and welcome to my tutorial. Today we'll be talking about web workers, what they are, how to use them, demonstrations, live coding, all kinds of dangerous stuff. Now originally this was going to be done in 15 minutes, but this is my 7th time, and every single time I do this intro, this is my 7th time making this video, or at least this intro, and every single time I failed because of one reason or another. So this time I'm throwing the time limit out of the consideration. And if it takes 15.5 minutes, if it takes 14 minutes, if it takes 20 minutes, I don't care, it'll be done. So without further ado, I'm going to turn off my webcam. Nobody needs to see my pretty face while I'm explaining all of this. And let's talk about web workers. So what is a web worker? Well, before we get to a web worker, let's talk about how JavaScript is parsed and how it runs in the browser. Whenever you open a new tab, and I'm going to talk in terms of Chrome because I know Chrome the best. Whenever you open a new tab, a bunch of cool stuff happens. Chrome fetches the page, it parses the HTML, parses the CSS, parses the JavaScript, runs the CSS in JavaScript, displays all this kind of stuff, right? The thing is that whenever you do that, the JavaScript is run single-threaded. And I'm sure you've heard that before about Node, but it runs single-threaded in the browser as well by default. And I guess there's not really an option to run it multi-threaded, except with the worker. So what happens is that whenever you have some expensive calculation or expensive processing to do on the JavaScript thread, it locks up the user interface. So you click on a button, it doesn't work because the JavaScript is running. You try to type something in and the typing becomes laggy because JavaScript is running in the background trying to do something. And that's a problem. And the way that problem was solved in the past was just sending that command back to a server, and that server doing the computation and then just coming back with an answer. That's how you basically do expensive calculations. Or you would just show a loading bar that tells the user that, hey, your UI thread is basically locked up and you can't do anything. You gotta wait until this stuff is done. And that really sucks. And what sucks even more is when these calculations, don't happen at the click of a button, but keep happening continuously as you run through the page. And what you really need is be able to asynchronously offload that somewhere and get the responses back just at some point. It doesn't have to be immediate. So the way to really deal with this is using the web worker. The web worker I like to call the little server on the front end. The web worker is basically just having a separate JavaScript thread that's not connected to a user interface, that's not connected to a DOM, that you can send messages to or actions to, and it can respond back. And it's a very simple messaging system, and you can create your own protocol on top of it to make it a little bit more understandable, and it works fine. So that's what basically a web worker is. It's a separate JavaScript thread, right? A separate JavaScript thread that is not connected to a tab or directly connected to a tab, and you can access it from your current tab. You can just say, run this expensive calculation, and it'll run, and you'll see it in the task manager, on Windows or whatever the hell it's called on Mac or Linux. I guess HTOP on Linux, and or top, and and it'll run its calculation, but your UI thread is not going to be blocked, and you can keep doing whatever you were doing on the front end on the UI, and that's great. The caveat is that the web worker does not have access to the DOM, which is okay. It does not have access to the window object. It has a self or this object, and those have their own properties. But one thing you'll immediately notice is that it's missing is literally the DOM related stuff. So without further ado, let's go ahead and build the simplest web worker we can. So let's build the simplest web worker that we can. I already created a few files because I've recorded the segment so many times that I really just don't want to do it again. And let's look through these. We have an index.html, which is basically index.html. We refer here to main.js, which is our main JavaScript file that has access to the UI, and we'll call the web worker eventually, once we're done with this exercise. Let's go ahead and look at that main.js. To check if a web worker is available, it'll be on the window object. And let's go ahead and add it. My backspace doesn't work in Vim, so you might see me kind of stumbling around a little bit. I apologize for that. And, whoop, there we go. Okay, so I'm going to create a worker, and it's as simple as doing new window.worker, and then you have to pass in the name of another JavaScript file. We're going to call ours worker.js. Let's go ahead and create it. All right, so what's going to happen is that Chrome or whatever browser you're using is going to fetch that file, worker.js, is going to run it, and it's going to make it available as a worker for you. Let's make sure that it does run. Whenever you do a console log here, though, I can't remember if you can actually see that it works or not. So web worker is running. Let's see if that works. Yeah. Web worker is running. That's great. So we have access to console log from both of these threads. The reason why I wasn't sure that it's running, or if it is running or not, is because these two files or these two JavaScript threads do not share memory. Whenever you have a variable in main.js, it's not accessible from worker.js. And actually, if you pass in, if you send variables between these two threads, the values are copied rather than keeping the same reference. So the way to send messages to the worker and to communicate is via the post message command. So we'll do my worker dot post message, and then you just pass in whatever you want to pass. I'm just going to call it my message. On the other side, on the worker, you have access to an object called self. So we'll do self. We'll do .add event listener message. And we'll have an E. All right. And then we'll just console log it out. Let's just console log out the entire event so we can look over it. Great. So we have a message event. It's a basic regular message. The data is here, my message. All kinds of cool stuff that you can read about. You know, you can look at. I don't even know what most of these are used for. Current target. You know, that's the dedicated worker global scope. Global scope is actually just the scope of the entire file. Like I said, all kinds of cool stuff. We'll just go ahead and do e.data because we want to just see the message. My message. Perfect. And on this side, we can actually send messages back to the main thread. Before we do that, I want to change this a little bit. I'm a huge fan of Redux, and I'm a huge fan of Flux. And so let's go ahead and format this message in that same way. I found that whenever you have a messaging system between two different files or two different services, it's good to come up with a convention. I like the convention of using the standard Flux action, the SFA. I think that's what it's called. I'll have to check on that because it's a very simple protocol. You just send a type, say message, and you send a payload. Backspace doesn't work. There we go. Nope. Payload message, my message. I'm a huge fan of this convention, and on the other side, we're going to listen for it, and we'll just create an if statement. I don't want to get into switch statements right now. If e.data, let's call it an action. Next action equals e.data, and if e.data type is equal to, whoops, if action type is equal to message, we'll just log it out. You're not supposed to do side effects in Redux, but oh my god, this lack of backspace is gonna really annoy me, and the indenting is gonna annoy me too. You're not supposed to do side effects in Redux, so it's okay. We're not really doing Redux. We're just using that convention. Payload message, and that should do it. And let's see what happens. My message, perfect. So it's working. Next, we're going to look at how to send messages back from the worker to the main thread. But one of the things that I really want to point out here is just how simple this is. You're basically sending events back and forth from one to the other worker. And honestly, I don't think you need much of my help from this point on, but I'm going to keep diving into what else you can do with a web worker. So I decided to take a little bit of a break and try to fix my Vim backspace issue. All right, and it looks like everything works. So now that we're listening on a message on in the worker, let's say we want to send something back. I'm going to add an else if And I'm going to create a new, I guess, code branch here for the action type calculate. And all I really want to do here is send a message back to the main thread with a result to some calculation. So let's just say that we're going to get an object. It's going to have two values, and the first value is going to get multiplied by the second value. We'll do self dot post message. So similar syntax as the main thread. And we're going to send back result. And the result is action.payload 0 times action.payload 1. Let's call it multiply, actually. Multiply. All right. And you can imagine that in real world, you might have a much more complicated calculation set, like the Fibonacci sequence or something like that. And we have that on the worker thread. And let's go on the main thread. Here, we have to add an event listener. For a message. And since we're getting the result, well, you know what? Let's go ahead and keep up the same convention that I was using in the other way. So whenever we want to send a message, it's always going to be a like a redux or flux action. So we're sending back an object with the type result and payload result. And I talked about how variables are copied. So this object is deep copied into the main thread. So if you update something in the main thread, you don't have to worry about messing up something on the worker. Type result. Oops. We're going to capture the data again. We're going to check if the data type is result, and we're just going to log it out. Result. Is this what I set up here? Yeah. All right. Okay. Now we just have to fire off the message. Again, we'll specify type, multiply, payload, and we're going to do the number 5 times 5, bar times 6, so that should be 30. All right, let's see what happens. Nice. So we have the result. As you can see, it's actually pretty simple. You just keep sending these messages back and forth. In this situation, yeah, you can create your own protocol, but again, I really like the idea of using the standard flux action or whatever it's called. I really can't recall, and I might have to look it up. I really like using that. I've also seen people use something like HTTP, where they have like a header or like an address and then like something like a router trying to figure out what that main thread is asking for. All right. The next thing we're going to do is actually demonstrate why this is a good idea in the first place. We're going to run Fibonacci, and when I say Fibonacci, I mean a really inefficient implementation of Fibonacci. So let's go ahead and do that here. We're going to create a function called fib that takes the argument n. And so what I really want is a digit that whatever the result is in the Fibonacci sequence for this number sequence, for n number sequence. And I'm looking for my equation that I wrote out here. in my notes. All right. Very rudimentary if n is less than or equal to 1. We return it. This is the end of our Fibonacci sequence. And if it's not, then we utilize recursion. One thing I'd like to do here is do a console.time. I don't remember exactly let's see. I can't exactly remember the syntax for console.time, so I'm going to look it up real quick. And we're going to go ahead and time our Fibonacci sequence, how long it takes, and it's going to log out the time. So we have time and time end. Perfect. Console time. And since this is blocking and we don't have to worry about async, I'm just going to say fib plus n is going to be our key, and we're going to go ahead and end this here. Oops. And over here as well. All right, let's try this out. You can see I'm not sending it anywhere yet. Just wanted to make sure that it's available. This is not what I was thinking about. This is not what I was expecting. All right, let's create a wrapper function real quick. Fib calculator. And what the fib calculator is going to do is do our timing for us. It's going to fib n. And that's going to return the result. So I wrote that a little bit of a blunder. There was a little bit of live coding, and as you can tell, live coding is not the best thing to do. So we have a pure Fibonacci sequence function that's going to recursively calculate our Fibonacci, and then we have a fib calculator that's going to just time how long everything takes. All right, so fib calculator. So 0 milliseconds, let's try 10, 0, oh, okay, 30, perfect. Let's see how long we can ramp it up. Ooh, 40, that's interesting. Nice, so that's about 3 seconds. I think that's pretty doable. Let's see what's gonna happen if we do a 45, the sequence number 45. I want it to be a good 5 seconds before it works. A little bit longer than 5 seconds. Oh no. I forgot that it's exponential. So 45, this might take a while. Well, let me demonstrate what I wanted to show you. So while this part is interactive, you can't interact with the UI. I can't select hello. If I go into elements, it's blank, and you can't see anything. Oh, it took a little while to load up. Oh, it's working, and that's because the function finished. Perfect, so that's 35 seconds. I don't need that long. I'm gonna go ahead and do it 41. Okay, so non-blocking, I can select hello, I can go into elements, I can inspect DOM. If I do blocking, which will be at, if I do 42, it shouldn't be 41, it shouldn't be too bad. I can't select anything, nothing highlights. This doesn't work. Now it works. Yeah, 5 seconds, perfect. And this is the exact kind of, best showcase of why would you use a worker. Whenever you do an expensive calculation like this, you block everything. You can't do anything with the page, and you can't close it out because Chrome keeps waiting for the JavaScript, for everything to finish working. So let's go ahead and move it to the worker instead. And I'm only gonna move the fib function to the worker. And see what happens if we run that same thing on the worker. What happens to the UI and what happens to the time. So we'll have a fib action, and we're gonna do, whoops, what am I doing? We're going to do, let's see, constant results, so fib action payload, and then we're going to do, then we're going to send a message back. All right. So now if we run the fib function, if we ran it from the worker thread, it would be just on the worker thread. When it finishes, it'll send out the result. So we're going to just modify our fib calculator to send out the request to run that fib function. Let's see. Just realized that actually I have to have the entire timer on the worker. So let's do that as well. There we go. Calculator. All right. The reason is that because this is an asynchronous action, once you run that function here, it'll actually get a result immediately, and it's going to be incorrect. So let's go ahead and do this fib calculator. We're going to still call it the same thing, and we're just going to send this out. I want to be on the right scope. My worker post message. All right, type. What am I thinking of? Oh, fib and payload n. All right. Whoops. There we go. Okay. So now if we run that, it should be running on the worker thread. Unexpected token. What did I mess up? Oh, there we go. Else. Okay. So this is our first Fibonacci. Wait a second. I didn't mean for that to happen yet. Okay. Oh, okay. It's doing the multiplication. All right. So fib calculator. I'm gonna do 5. All right. We get a result of undefined. That's what I was saying, that it comes back immediately. It runs on the worker thread, takes 1 millisecond, and the result is 5. That is not right. Is it? Maybe it is. Huh. Okay. Let's go ahead and try 40, which takes 3 seconds. So 1, 2, 3. Took just about the same amount of time as running in the main thread. So we're not actually getting any, we're not getting faster speeds from the get-go. But let's try that 45. That took about, I'm gonna try 44 so it doesn't take as long. And this locked up the UI thread, and it doesn't lock it up here. I can do whatever I want to. I can inspect the DOM. I can run other calculations. In fact, let's run the fib calculator again. The messages queue up, so until one message is done calculating, you're not going to actually get a second message. All right, came back. It took 20 seconds, and we got the result. And then the second one ran, and you can see kind of the order of the ways that things went. You get the first result first, and the second result second. And no UI, no UI locking. You could do whatever you wanted to do. I could run a second function right away. There was no issue. And this is pretty much the crux of the magic of the web worker. You're not necessarily getting any speed gains by running it on the worker. You're just getting better responsiveness, and you avoid locking up your thread. Yeah, so it can be used for a bunch of different stuff. Lazy evaluation, Redux. You can always send a message to the worker instead of to Redux, and then the worker can calculate the new state and send it back. You can definitely do that. You can run all kinds of other stuff on the worker, fetching HTTP requests, parsing JSON, again, doing expensive math. If you're using Excel or something like that, maybe you want to, if you're creating something like Excel, maybe you want to evaluate your formulas, after some delay, that you don't have to necessarily have the response right away. There's so many different applications, and just the majority of it is if it really locks up the thread for a noticeable amount of time, if it locks up the UI, the DOM for a noticeable amount of time, you might want to throw it onto the worker thread, unless you can send it back to the server or whatever else. The advantage of not having to send it back to the server is the fact that if you're working offline, you can use a web worker. One last thing that I'm going to do before we leave is before I'm done with this is show you the syntax for importing scripts into the worker. So I just demonstrated that the worker is actually a separate file that gets imported. Well, the worker can import other files as well via the import scripts keyword or import scripts function. What this does is basically copy the contents of this the target file into this file. There's no encapsulation. There's no, I don't know, making sure that the scope is not tainted. Tainted. It doesn't. You can't save it into a variable. It's not a require thing. You can't do this. It just copy pastes this file into with the worker.js, and we'll just go ahead and create one. So we'll create utils, and utils is actually going to be the host of our Fibonacci and Fib calculator functions. There we go. And if I did everything right, we actually shouldn't see a difference in the way this works. Fib calculator 5, and this time we see that it actually comes from utils, but it stays here. But it's still visible. It still works correctly. So that's it. That's it for my little tutorial lesson today. I just wanted to demonstrate how to use web workers, that they're pretty damn easy to use. There's nothing. I would say that sending HTTP requests is a much bigger deal. I want to show you, what you can use it for. And yeah, that's it. I hope you enjoyed the video. Please leave a comment, subscribe, like, all that stuff that you should do for every video that you ever see that you like. And I don't know, go ahead and browse my channel and enjoy some of the other videos that I have.